let's start. Maybe let's start with Anand and then go down. Anand, we can't hear you if you're speaking. Maybe let's start with Ben and then go up. Maybe that's better.
Okay, yeah. So I think I've talked about how Ethereum infrastructure works in the back end, and I think it's to do a quick overview. I think you can look at the read the things for this, but basically, originally there was just sort of Geth and what's called now execution clients that did everything. Then during the merge, what happened was you had sort of this new beacon chain, which is proof of stake that eventually the execution what became the execution clients latched onto for a consensus. So you have sort of half the system basically on a side chain that just handles consensus, and the other half of the system, processing your Ethereum transactions and so on. And basically the execution client does all the heavy lifting of what goes on like on chain, and the consensus client just tells it, all right, this is what the chain looks like, this is the next block, this is sorry, this is staked or consensus or finalized. I have my I think I've talked before about how I there's some part to this that like they went and they said, all right, we want multi-client, so let's have like various clients based basically on the different programming languages. And I think these are all funded by EF or various EF related things, Ethereum Foundation. And I mean, I don't know how it's evolved over the past 3 or 4 years. Like it could be that now, like each team is much more focused on what it's trying to do. But at the beginning, they were all sort of like basically copies of each other in different languages. And I do support multi-client, and I think that it's an important thing. But I always thought, they each team should be trying to specialize in something user facing. Let's say, like maybe there should be a node that's particularly for some kind of user, or one that's maybe some other kind of user, and then focus instead of just having it based on being technical architecture that the user might not care at all about. Like, do you really care what your node language is written in, or do you care like it has some kind of feature or anyway? Um, but it seems like that did work out well enough. They do have like 4 client teams. I also think that this, having run my own Ethereum nodes, having to deal with like okay, you want to have two fundamental executables communicating each other with through an engine API. That's fine. They really ought to be packaged together better. It's very much a bike shedding thing of like, do you want to use Geth and then which execution client? And we've worked very hard to make sure they can all mix and match. And there's some advantage to making sure that you can mix and match them, because that means that the system is more robust, less chance of failures and people try to do weird things. But it's also like, why is it not as easy to run as download one thing and then it bundles those two things together and then it just plug and play. I think they eventually came up with something like that, but I know for a while it was kind of rough to I basically had to set up two things and have them hooked together instead of just it really should be easy. But yeah, I think that's pretty much a nice overview. I'm not sure if I have any like focus thoughts on this because I've thought about it so much already. But yeah, if anyone has any questions, I can probably work with you to answer them. You think we're passing up then?
Yeah. So, well, I every time so we have read parts of this here and there, like the consensus, Casper FFG and LMD Coast. So like every time we read something related to the entire thing, like at least my understanding goes a little bit higher of what it was previously. So like I always used to think, why do the consensus layer and execution layer both need like the peer-to-peer gossiping, and like what is happening there. And basically, like, now I understand where the basically like the execution layer is where first the transactions go and where the mempool is formed, and then basically like it's the consensus client that basically proposes the block. So better understanding of that. But basically, like, I made a small note of the entire consensus client architecture. So they have like a uh, uh, beacon node which handles the peer-to-peer networking, and then the validator client inside the main client, which basically is signing the blocks, and then the consensus engine which uses LMD Ghost and Casper FFGs. And then there is an API part which is talking to the like there are two three API parts, like the engine API, which talks to the execution layer, and the beacon API that is talking to the validator client. And then there are some databases for maintaining the state of the beacon chain. So yeah, so basically that is what I have understood. But like this, uh, it basically shows like you need to understand a lot to just run a client without any problems, right? So like if there is some problem, then if you don't understand all these parts, then like how would you debug it? So it's not like the Bitcoin node that you just run something and then it keeps on running, and then basically like it's like an executable. But here it's like there are so many moving parts. And I've tried to run this node, I think like a few months ago, with some what was it called? There was some client that was like packaging this into different combinations. That was a little easy to use, but like it was not fully there. And there is also one client called Sedge tool from Nethermind. I have not tried it yet, but like that's on my to-do list. Uh, but yeah, it's still not that easy, I would say. But like maybe there is some better way. Yeah, those were some initial thoughts. Passing on to Anant.
Can you hear me?
Yes, we can.
Yeah, okay. Sorry about that earlier issue. Yeah, I mean, I guess similar to Anurag, my understanding perhaps goes a little bit uh, better or deeper with every reading. But I do think like without LLMs, it would have been way harder to sort of have any deeper understanding beyond the surface level understanding. So yeah, I guess LLMs are sort of important part of the diffusion of blockchain technologies in some sense. And I was basically went around looking at uh, like what are the different clients and like who uses those clients and like who builds them and so on and so forth. It seems like Lighthouse is at least from the doc, it seems like Lighthouse written in Rust is considered top tier, and I'm not sure why that is top tier. I need to perhaps develop a better understanding next time around. But it did sort of, I did find it interesting that there are sort of uh, with institutional adoption for Ethereum, and I'm supposing people are going to be running nodes and running clients. It seems uh, like a strong emphasis on not centralizing or not just using one client, and the sort of the client diversity emphasis seems, I guess, interesting. Especially, I mean, I also went looking, was thinking about maybe recently Vitalik posted about how the L2s perhaps didn't play out as what was originally anticipated, and kind of and I guess in another one of the tweets, he hinted that how some of the institutions can run like what he calls as app chains, basically their own L2s, and just post like a fully permissioned, provisioned updates, but they just post back to L1. So uh, I'm not sure how what all of those things mean for the sort of consensus layer going forward. Anyway, those are things I was thinking about. The other thing this time around, I think I got a better understanding of the PPBS, the proposer builder separation that happens in the consensus layer, and uh, again, that seemed like it was a sort of a reaction to, I guess, standardized. MEV in some sense, uh, make it sort of fair for all sort of node runners. But again, in the face of all this institutional adoption and all these different ideas being thrown around, I'm not sure what that means going forward. The last thing I was trying to attempt today, perhaps I didn't have time, is maybe try and make a visualization or like a uh, something of that sort about the consensus layer with AI, of course, and see where that goes. But I'm not sure if I'll get that wrong. I'm not sure if I even know to say if what makes this correct or not. But something I'll be playing around perhaps. Don't have much any other thoughts. I'll pass it down to Venkat.
Venkat, you are muted if you are speaking.
Yeah, sorry, I was doing some cooking. So, yeah. So, yeah, same as others, I spent some time circling it for the nth time and getting some marginal improvement in my understanding. Yeah, this time I was asking a bunch of questions, trying to get like, I guess, Fermi estimation type intuitions about like the fundamental logic of what's going on. So first I asked about the history of where the current field design came from, and that was kind of interesting, where it talks about like how it went from an original proposal where it was kind of like a, I don't know how to describe it. The notebook LM, you guys can't see my chat, right? But anyway, so the very first version was actually something called the friendly finality gadget, which is kind of meta consensus that would periodically just bless the chain with finality, so with proof of work. So that was the first proposal. And then it kind of evolved from that in some very interesting ways. And now we've got like the modern beacon chain model, which apparently consists of two different pieces, so Ghost and Casper. So interesting thing is conceptually, Ghost is about basically solving for liveness, and Casper is solving for finality. And there's obviously a tension between the two. And Ethereum overall has made the architecture decision to prioritize liveness over finality, which means that the change can like not finalize for a long time, but still remain live. And then liveness is slowly restored as validators get kicked out for inactivity, and the supermajority consensus is restored again to restore finalizing as well. So that was kind of interesting. I also explored a little bit where the 32 ETH minimum stake comes from and how it plans to go to 1 ETH. So 32 ETH comes from bandwidth and processing constraints at the at the EVM level, I think. But anyway, so it's not an arbitrary number. It comes from somewhere. Um, and the other big design consideration is time to finality. And the holy grail is single slot finality, but right now it takes apparently 2 epochs to finalize. And this feels, from what I understand, somewhere between an arbitrary tuning knob and sort of like emergent number that comes out of like the actual process itself, like how long it takes for again, I won't try to explain that, but I thought I understood it. But yeah, so it's not a purely arbitrary number. Why 2 epochs of, I think it ends up being about 6 to 8 minutes or whatever. That's an artifact of both arbitrary design choices and how the fundamental process works. So that was kind of interesting. Then I asked about how EL and CL interact through the engine API and learned a couple of things there. And finally, I asked about Justin Drake's new proposals for Beam Chain and what that would involve. And looks like, yeah, it solves for two things. One is it lowers the stake to 1 ETH by primarily using ZK. So because ZK based verifications are very much cheaper. That apparently drops the staking price down to 1 ETH. What else did I talk about? Finally, I was talking about how validators join and leave the network. So that was an interesting part of the chat about you turn on the software. There's a waiting period. You put in the stake. There's you basically have to wait some time to get trusted. Then you start getting blocks to propose and start earning money. And you can leave by yourself. You can get kicked out for, of course, double spending and all those violations. So that apparently kills your stake from 32 to 16 and immediately drops you. Uh, and what else? Yeah, there was an interesting thing about if operator wants to swap out their current CL client for another one because maybe they want a different software um, for the client, there's a whole process for that where they still kind of retain the node's identity. So it's, trust and stake and things like that. But they very carefully go through a process of swapping to another software, which I hadn't thought of that contingency at all. Like what happens if the software an operator is using, the consensus layer client basically, has a major bug in it, and on very short notice you have to uh, swap it out for another client software. Do you lose your stake or something? So apparently they thought of that, and there's a process for that. So that was an interesting new learning for me. Anyway, yeah, I'll stop and to Jenna, I guess.
Yeah, I'm having fun with. I've been trying to think about how to make my brain sort of engage with this stuff differently. So now I'm making quizzes. You guys are welcome to play. But the short answer were I really like thinking of my question that I gave to Eigencloud, which is so as a normie crypto using citizen, what's the cool, what's useful to know about all this? And the one of the ones was if you're going to stake your ETH, where it matters where you put it. So that's kind of neat. It's in fact in effect a governance play. So whether you give it to Coinbase or somebody else, so giving it to a medium to small player, I need to know more about how would I choose that. But that seemed like a useful thing. Excuse me. It brought up the finality question, which Venka was just talking about. It's I don't move big money. It sounds like that's more matters for people who are moving big chunks of stuff around. Um, but then I also thought of asking about, so who is it that's got 32 ETH to become a validator? And it made the interesting point that that number was chosen back when that would have been kind of affordable, and it's not anymore. So we've got, what did it call it? We have a plutocrats running the validators, so we're back with that same problem. So I'm sure you guys all know more about it than me, but that seems really like a big problem to solve. And so if anybody else has found something interesting about the other answers, I dropped it in. And if we have time, we can do the quizzes together. That would be pretty funny. Passing up to Ananth now.
I think Anand spoke already. Just one comment about the 32 ETH, right? So even let's say like if ETH's price goes high, uh, then even then in the developing world, like one ETH is costing a lot. Like so people there wouldn't be able to run a validator node there, like or at least like a lot of people wouldn't run it. So it's like even yeah, I don't know like how like normal people there is pooling solutions of course, but like I don't know how that works.
Yeah, good point. That's a completely non-trivial thing.
Yeah. So the fundamental issue here is that every sort of person who wants to interact with the validation has some overhead. Like they have to sign, and yeah, there's signature compaction basically, where you can compact all the signatures for like all the attestations into like one object. But there's still some overhead there. So like if you have someone wanting to attack the system, spin up a billion validators, they could crush it. to where it's not really functioning anymore. So there has to be some limit. The question is like, what limit is that? How should we, define that? What happens when, as things improve and it becomes easier on the chain to have large numbers of validators and so on? And how do you want to handle that as that scales? But and there's also the fact that it was originally 32 ETH, and now they want to make it less, but a lot of people that 32 ETH doesn't go away. So a lot of people, so like if you're coming in with like a fraction of an ETH, um, is that what we want to allow, or so on and so forth. So it's definitely interesting.
I was going to say that I think liquid staking and also restaking does actually democratize, I think, enough for a lot of like concerns. Yes, it's still very hard for like people in the developing world to do it, but it's not that bad. Like even in a place like India, many people are rich enough to run a node and then run a staking pool on top of it. And then when you get to restaking, like what EigenLayer does, a lot more happens. So I think restaking is a good enough solution for dealing with like the affordability problem. I think a bigger centralization issue is so many of the transactions enter the mem pool through just a handful of RPCs. Like back in a few years ago, there was only I think one or two Infura and the other one. Now there's more. I think there's 4 or 5. But still, these people have like managed pools of nodes, and that's where like 90% of transaction flow I think enters the network. And I think that's actually a bigger centralization problem than staking being unaffordable. um, I'm not sure that there's any proposed solution for that. So that might be interesting to look at in a future call. Like, what's the state of RPCs? What percentage of nodes do they run? What percentage of transactions do they handle? Because the only alternative to RPCs is to run a full node yourself and like submit your own transactions as a full member of the network, which as hobbyists, very few people do. Like the only economically rational way to do that is if you're either running an exchange or running an RPC. If you're not doing either of those things and just running a node as a hobby, you're like, I don't know, spending a lot of money running infrastructure and not really probably getting enough rewards from like block building and stuff to justify it. So I think the RPC problem is more important than the staking level.
Aren't these RPCs generally like infrastructure providers, so they already make money via some other ways, and then they are providing this or something?
I think so. I think Infura is owned by what's that consensus.
Consensus, yeah.
Yeah, but we should. I think this is worth a session. I haven't yet fully explored how the RPC sector works, but it's better than a few years ago. Like when Moxie wrote that article, I think we read it a couple of years ago. His main criticism was about concentration in Infura and the other one. I keep forgetting the other one. And now the situation has improved. And also similarly, the sequencer market in L2s. So these are the two big centralization failure points that I think we need to understand.
Okay. Any more comments, thoughts? If not, we meet in 2 weeks. Thank you. Bye. Bye.